Alright, so I'm going to be talking about types of membrane transport. And on the surface level, there's two types, passive and active. We're going to start off talking about passive transport. The first type of passive transport that happens is diffusion, which is the spontaneous movement of solutes, both molecules and ions, from high concentration to low concentration. So think there's like a cup with a membrane dividing it in two different types of molecules on both sides. The molecules are going to pass through that membrane to equal out the concentration on both sides, and they'll do that passively. There's no ATP or anything driving that action other than the need for the sides to have equal concentration. Sometimes, however, there are molecules or ions that are too big to just pass through the membrane, and so they need facilitated diffusion, which is where transport proteins will help bigger molecules and ions to pass through that membrane and go where they need to be. So a channel protein is going to always be open, and it's always going to be letting things outside the cell in the cell, the proteins that need to be there. And then transporters, or carrier proteins is the best way to use it, are proteins that kind of open up to accept a molecule that needs to go from one side to the other, and then close and then open out the other side to kind of spit it out into the place that it needs to be. And within facilitated diffusion, it's important to talk about osmosis as well. And so in the previous subjects that I've discussed, the molecules have been what's moving, but in osmosis, it's the water that moves. The water is the solvent in this case. And what it's going to do is move across the membrane to not equalize the amount of molecules on each side, but to equalize the concentration on each side. So if on the left side of the cup that we talked about earlier, there's 5 molecules, but on the right side there's like 500, the water is going to move from the left to the right, and there's going to be a lot of water on the right side and not a lot on the left side left over to equalize out those concentrations. And with osmosis, it's also important to discuss tonicity, and there's 3 types of tonicity. First is isotonic, which is what you want, which is there's equal water and solute on either side of the membrane. Hypertonic is when the solute concentration is higher and the water concentration is lower on one side of the membrane. And hypotonic is when the solute concentration is lower and the water concentration is higher on one side of the membrane. And that was kind of quick, but the best way to describe these is through what they do to a cell. So in a hypertonic solution, there's a ton of molecules outside of the cell, and in order to equalize the concentration both within the cell and outside of the cell, water is going to leave the cell and go equalize the concentration outside of the cell. And when it does that, the cell is going to shrivel up, and it's not good for the cell. You don't want like a shriveled up cell, so you don't want that. And with hypotonic, it's the opposite. There's not a lot of molecules outside of the cell, but there's a ton in the cell. And so water, in order to equalize that concentration, is going to rush into the cell, but there's going to be too much water eventually, and the cell is going to burst open, and obviously we don't want that to happen to us either. So isotonic is what you want, because the concentrations are the same and water just kind of free flows in and out with no real change, and that is the ideal. So that was passive transport. Now we're going to talk a little bit about active transport. There's 2 types of active transport: primary active transport and secondary active transport. Primary active transport uses ATP to get things against the gradient. So previously all those things that we talked about were going with the gradient, the concentration gradient, but sometimes things and molecules need to be where they need to be, and it's against the gradient. And so in primary active transport, we use ATP to get things against that gradient to the other side. And secondary active transport doesn't use ATP, but it uses a pre-existing gradient that was already made to drive that active transport across the membrane. And there's a lot of ways you can liken this to the gospel, but for me, I think about how all of these molecules and ions need to be somewhere. There's a certain place they need to go, and we as people, we all eventually need to go back to the presence of the Father, and we need to hear the message of the gospel of Jesus Christ and have the opportunity to accept it. And we know that whether in this life or the next, we're all going to get an opportunity to do so. And the opportunity that we get, each person is a little bit different. Some of us grow up in the church, but even within growing up in the church, there's lots of different types of families, some teaching a lot about the gospel, some not, some providing good examples, some not. And whether you're outside the church, sometimes it's the missionaries that will knock on your door. Sometimes you'll see an ad on Facebook, or see something on TV, or have a neighbor, whatever it may be. God will always provide a way for us to hear the gospel when the time is right for us, whether it's in this life or the next, just as our body makes sure that all of our cells and ions have the opportunity to be where they need to be. And so that's how I would liken it to the gospel.